and system of parallel forces we will be seeing, and couple. Okay, so just let us take a very small example of couple. Suppose we are having one hinge over here and one door is attached to this hinge. Suppose a door is attached to this hinge. On this side of door, a person is standing which applies a force of 50 Newton. Okay, and this is at a distance of how much? This is at a distance of 1 meter. Suppose here two people are standing at a distance of 0.5 meter and at a distance of again 0.5, distance of 0.5 meter. It again applies the force of 50 Newton. It also applies the force of 50 Newton. Now, before starting all these things, let us first define what is a moment or a couple. Moment or couple is nothing but ability of a person to give turning movement. Ability to give turning movement. Suppose this person applies 50 Newton of force at 0.5 meter distance of the door. So how much couple this person is applying is 50 into 5.5, which is 25. 25 Newton meter that person is applying. 25 Newton meter. So this person is giving the ability to turn this door by a value of 25 Newton meter. This person, the another person, is also applying 50 Newton force on this point of the door, and this person is applying the force at 1 meter. 1 meter. So the couple or the moment becomes 0.5 into 50, sorry, 1 meter into 50, which is nothing but 50 Newton meter. Why I have written 1 meter? Because the distance of force applied by this person is 1 meter. It is 1 meter from this particular hinge. So although both the people are applying same amount of force on the door, but the other person, this person will easily open the door, will easily push the door, because the moment applied by this particular person is 5 Newton, is 50 Newton per meter, is 50 Newton per meter, and the moment applied by this particular person is 25 Newton per meter. So more the moment applied, more easily the door can be opened. So in the practical example also, if you go to the door of your house and you apply a force over here at a particular distance, you will find it very difficult to open the door. If you apply the force over here again, that difficulty level will reduce. Similarly, if you apply the force over here, you can easily open the door with very less movement or very less ability. Okay, so this is nothing but couple or movement. So this movement or couple is nothing but force into perpendicular distance. So this couple was force into this perpendicular distance. Okay, so understood what is this couple? Couple is nothing but ability to give turning movement. Okay, now let us see. So the total couple applied by this particular person, say this is person A and this is person B. So the total couple applied by person A and person B in anti-clockwise direction. Anti-clockwise direction, person A is applying force like this. So you can see the turning movement will be in anti-clockwise direction like this way. Again, person B is applying the force. So the turning movement will be like this way in anti-clockwise direction. Okay, so in MD Dayal ka book and in many books, the anti-clockwise movement is considered to be positive and the clockwise movement is considered to be negative. So the total movement applied by A and B is nothing but 50 Newton meter. Sorry, is 25 Newton meter. I'm talking about total couple applied. So 25 Newton meter plus 50 Newton meter, okay, which gives me 75 Newton meter in positive direction which is 75 Newton meter in anti-clockwise direction. Okay, this it can be written as like this. So this is the total couple applied by A and B. Okay, now the couple applied by the person on the other side of the door is 50. Sorry, the force applied by the person on the other side of the door is 50, and the couple applied by this person is 50 into 1 meter. 50 into 1 meter. So this person C applies a couple in clockwise direction like this, and clockwise is considered to be negative. So the couple applied by this person, the rotary movement by this person is 50 into 1, which is nothing but 50 Newton meter. 50 Newton meter is the couple applied by this person. Okay, so the total couple by A and B is 75, and the couple applied by C is 50. So these two person are applying cumulatively more movement, so this door will open on this side. So the door will open on this side. What will be the resultant couple? The resultant couple will be couple by A plus B. Okay, couple by A plus B plus couple by this C. So couple by A plus B is 75 Newton meter, and it was positive because it was anti-clockwise, and couple by C is negative because it is clockwise, so it is 50. So the resultant couple is 25 Newton meter. So by this 25 Newton meter, the door will open on this particular side. So this is the general definition of couple, the resultant of couple. Okay, the resultant of couple. So the next topic that we will be seeing is system of coplanar forces. We will be seeing system of, we are having this question from the system of coplanar forces. Here they are saying determine the resultant of parallel system of forces. Again I repeat, determine the resultant of parallel system of forces. Here we have system of coplanar forces. This system I can draw, or rather it is already drawn. So determine the resultant of parallel forces. So see, I'm writing the answer. So they are asking resultant of the parallel forces. So the resultant of parallel forces is all the forces are in y direction. So it will be summation of f of y will be my resultant. Okay, so resultant downward going negative, upward going positive. So it will be minus of 200 plus of 500 minus of 350 and plus of 200. Total force value is nothing but 300. So my resultant is nothing but 300 Newton, which is positive. I will be writing positive means 300 Newton, which is going on in upward direction. So this is how you have to write. Now currently I know that my resultant is 300 and it is going in the upward direction. Like this way it is going in the upward direction. But currently I do not know what is the location of this 200 Newton, 300 Newton force. I do not know the location of this force. See, in previous lecture what was happening is we were having concurrent forces like this. We were having concurrent forces, and since the forces were concurrent, that is the forces were originating from the center, once we got the resultant, suppose this was the resultant, we knew that the resultant is going to pass through this center. We knew that it is going to pass through this center because it was concurrent forces. But these are not concurrent forces, these are parallel forces. So its location of resultant can be anywhere. It can be at this particular point, it can be at this particular point, it can be at this particular point. So we do not know at what distance from this point this resultant is. So we are supposed to calculate that thing, that at what point the resultant, at what distance does the resultant is there. Okay, so in order to calculate that, let me draw this system again. My point B, C, D and point E over here. Okay, now we will be using Verignan theorem. Varignane theorem will be used to calculate that at what distance from point A. See, you can select any point, other point, either you can select point A or you can select point C or D. So let me take point A. So at what distance from point A will my resultant lie? So for that we use Varignane theorem, and I am writing over here by using Varignane's theorem. Varignane's theorem states that summation of moment of all the forces at point A, summation of moment of all the forces at point A is equal to moment of resultant at point A. Moment of resultant at point A, which means if I take summation of all the moments, which is moment of this particular force at point B, C, D, E, and I add it up, that will be equal to moment of resistance at point A. So let me assume that this is that resultant is going in the upward direction. So let me assume that this is that resultant which is going in upward direction, and it is at a distance of point D, and it is at a distance of point D. Now let me apply the Varignane theorem. See, when I go for movement again and again, I am telling you that anti-clockwise will be considered to be positive and clockwise to be negative. You can consider other way around, but maximum textbooks are using this convention. So moment of force 200 at this particular point will be 0 because the perpendicular distance is 0. So here I am writing summation of moment at A for all the forces is nothing but 200 into 0. Then see 500 is going upward in the upward direction, this 500. So if I take moment, the moment will be like this, and the perpendicular distance is 3 meter. 3 meter is the perpendicular distance, and it is going in the anti-clockwise direction. So it is 500 into 3 is the moment. Then again this one is at a distance of 3 plus 4.5, 7.5, and it is also going in the anti-clockwise direction, movement around point A. So again I am writing here 500 into 7.5. Okay, so taking summation of moment at point A for all the forces, here the force 200 is at 0 distance from point A, so I am writing 200 into 0 plus this particular force 500 Newton is going in the anti-clockwise direction at a distance of moment will be at a distance of 3 meter. So it is 500 into 3 meter, it is positive. Then it is 350 Newton force. See, the total perpendicular distance will be this 3 meter plus this 4.5, which is 7.5 meter. It is going clockwise direction. So it will be negative. It is going clockwise, so negative. So 350 into 7.5. Okay. Then this force 150 is going in anti-clockwise direction. So it is positive 150 into 150 into 10, because 3 plus 4.5 plus 2.5 is nothing but 10. And then at the end we are having what? We are having 200 into anti-clockwise. It is again anti-clockwise. So it will be 200 into the total distance. The total distance from this 200 to the point A will be 12. Is 12. Okay. This is my summation of moment at A for all the forces. And it can be calculated as 500 into 3 minus 350 into 7.5 So which is 2775 newton meter. 2775 newton meter is the moment. Now what I had assumed is, I had assumed that, let me consider my resultant over here. This is my resultant, and this resultant, let me be with some other color. So this was the resultant. I had assumed that let this resultant be at a distance of d. Let this resultant be at a distance of d. So summation of moment, not summation, sorry, moment at A for resultant is nothing but, it is equal to, my resultant was 300 Newton, 300 Newton into my perpendicular distance. And it is positive, and it is positive anti-clockwise. I know the direction of my resultant. Okay, so this can be written as 300 into D is equal to 2775 Newton meter, which D is equal to 2775 divided by 300, it will be 9.25. 9.25 meter is the value of my D. Okay, so at 9.25 distance, at 9.25 distance, the resultant will act. So at the end, what we can draw is, we can just draw a diagram like this. We can draw a diagram like this. This is the length, and this is the point A, and at a distance of 9.5, at a distance of 9.25, the resultant will act, and the resultant is 300 Newton. This is the perpendicular distance, the perpendicular. So this is my answer. Resultant acts at 9.25 meter. 9.25 meter. Okay, so this is one of the question of finding the resultant. So we went very much slow for this particular question. Okay, you just remember that in concurrent forces, the resultant will be passing through the center. But here they are not concurrent. So we do not know at what distance from point A, from point E it is lying. So let us go on the next question. So this is the next question. Again, the question is, determine the resultant of the coplanar parallel forces shown and locate it with respect to O. Radius of the circle is 2 meter. Okay. The problem is not difficult. However, see, the forces are there in x direction. The forces are there in x direction. Okay, so let us start. See what they are asking, determine the resultant of the coplanar forces. So first thing that I need to calculate is the resultant of all the forces. See, it is very easy to calculate the resultant of all the forces. The resultant can be calculated by summation of f of x is equal to resultant, because all the forces are there in x direction. So I can write it as minus 150, minus 90, minus 100, and plus 200. Okay, so that will be equal to what? If we just take the calculator, so it will be minus of 140 Newton. See, when we get the negative answer, it is proper to write 150 Newton and then you show it in the diagram like this, in this direction. Now location of the resultant. For location of the resultant, again we have to use what? Varignan theorem. Okay, but before using the Varignan theorem, what you should be knowing, all the perpendicular distances of the force. See, in the last question, what was happening? In the last question, the perpendicular distance, the forces were parallel like this. The forces were parallel like this. So it was very easy to judge that this is the perpendicular distance. This is the perpendicular distance, maybe 1 meter or 1.2 meters. So this was the perpendicular distance from a particular point. But in this particular question, it becomes difficult to imagine, because if this is the perpendicular force, if this is, sorry, if this is the force, if this is the force, then what will be the perpendicular distance? What will be the perpendicular distance? Where am I supposed to take the moment? They have said that located with respect to point O. So I am supposed to take the moment at center, which is point O. Okay, so the perpendicular distance will be what? This will be the perpendicular distance. This will be the perpendicular distance in red color. Okay, you just imagine this thing, and this will be the perpendicular distance around point O. See, around point O, according to principle of transmissibility of force that we had studied earlier, according to the principle of transmissibility of force, this force can be shown. This particular force can be shown like this as well. This particular force can be shown like this also. So this particular point becomes, now it is easy to say that the perpendicular distance is this much part. Okay. So according to principle of transmissibility of the force, the same force can be shown in the upper direction, in the forward direction, and this is the perpendicular force. Perpendicular force remains same in red color and in green color. So don't get confused over the perpendicular distances. You can use the principle of transmissibility. You can, if you are confused, what you do is, in the examination, if you are confused, what you do is, you take this force, and then you go in the backward direction, like this way you go, and then you see the perpendicular distance. So now the perpendicular distance is easily visible. This is the perpendicular distance. Okay, fine then. Let us find this perpendicular distance. Let us find this perpendicular distance. How to find this perpendicular distance? You see, it is very simple. There is one line over here, like this. It is forming this triangle, and this is 60 degrees. This is 60 degree. They have mentioned that the radius of circle is 2 meter, and you want this distance, which is x. So the way you resolve the forces, the same thing can be done over here. See, whatever angle was touching this side was cos. So I can write 2 cos of 60. So this part is 2 cos of 60, and this part is 2 sine of 60. 2 cos of 60 and 2 sine of 60. So my distance is 2 sine of 60. Okay, so I'm writing over here, my distance is how much? My distance is 2 sine of 60 over here. Now the other perpendicular distances that I need to draw is, from this particular point I'm going in the upward direction. This is the another perpendicular distance. Again, what is there? This is 45. Angle is touching what? 45 is touching this particular line. So this line will be 2 cos of 45. So this will be 2 sine of 45. 2 sine of 45. Okay. Similarly, these are the perpendicular distances. This is the perpendicular distance. So 30 degree is with this line. So this is 2 sine of 30. This is 2 cos of 30. So this part will be 2 sine of 30. So again, this is the perpendicular distance. This is 2 cos of 30. This will be 2 sine of 30. This is how you can calculate the perpendicular distance. See, if you are unable to calculate the perpendicular distance like this way, you can also go for the simple formula, like, again, it is, say, 60 degree over here, and this is 2 meter. Then you can go for sine theta, which is opposite upon hypotenuse. Okay, so sine theta is opposite upon hypotenuse, x by 2. So what is your x? X is equal to 2 sine theta. This is how the basic fundamental comes, that the angle touching a particular side will become cos. So 2 cos of 60. This will become 2 sine of 60. It comes from sine theta and cos theta formula only. Okay, let us move in the forward direction. I have got all the perpendicular distances. Now what I'll do is, I will go for my Varignon theorem, which is, Varignon theorem says that, I'm writing Varignon theorem. So according to your Varignon theorem, Summation of moment of all the forces at O will be equal to moment of resistance at O. For now, I know that my resultant is how much? 140. It is going in where? In left hand side direction. So for now, I know that my resultant is, say my resultant is somewhere over here. Resultant is 140 and my resultant is going where? In the left hand side direction. Resultant is going in left hand side. But at what distance from O, that I don't know. At what distance from O, that particular thing I don't know. This distance I don't know. That I need to calculate. So summation of all the forces at O, I need to write it as like this way. First force is my 100 force. So I am writing for this particular force. This particular force. So 100 perpendicular distance is 2 sine of 45. So 100 into 2 sine of 45, and it is in clockwise or anti-clockwise direction. My center point is over here, so it will go like this. So it is in clockwise direction, so it is negative. Again 200, 150 force, 150 force. Again it is going in where? It is going in like this way. So it is anti-clockwise direction. So positive 150 into 2 sine of 60. 2 sine of 60. Now this 90 force, 90 force, and the perpendicular distance is 2 sine of theta. It is going like this, anti-clockwise direction. So it is plus 90 into 2 sine of 30. I'm writing over here plus 200. 200 is again going in anti-clockwise direction. So 200 into 2 sine of 30. 200 into 2 sine of 30, it is going in the anti-clockwise direction. This is equal to this particular part, which is my, how much was it? Was 140 into d, and let me assume that it is going in the anti-clockwise direction. See, like this way. So after calculation we get d is equal to 2.197 meter. So this is the distance. Answer can be represented like this way. You see, I'm drawing a circle from point O at how much? You see, the radius of the circle was 2 meter, but my value is 2.197. So it will be somewhat outside, which is 140 Newton. So this is how you have to show your resultant. So this was the second problem that we have seen. Let's see if any more problem. See, the problem is very much simple. I am just redrawing it, and it is called as a free body diagram. They are saying that the resultant of the force is vertical. If the resultant of the force is vertical, which means summation of f of x is 0. What they are asking? They are asking the value of f. Now, what is this f? What is this f? First, let us decide what is this f. Now, the f is nothing but tension in the wire. F is nothing but tension in the wire. And what is this tension? See, let me consider a rubber band over here. This is a rubber band. I am stretching this rubber band. I am stretching this rubber band. So at any point at the center, I can assume that there are two forces which are coming like this, and they are trying to hold the rubber band together. Okay, there are two forces which are trying to hold the rubber band together. At any point like this, again, I can say that there are two forces which are coming together and they are avoiding the rubber band to break. Means they are avoiding the rubber band to break. Okay, at any point, because I have stretched the rubber band, it is about to break. Why it is not breaking? Because at every point there are two such forces which are just keeping it together. So these forces are termed as tension forces. Whenever you stretch a wire or you stretch a rubber or you stretch any elastic material, there will be forces coming together to hold it, and such forces are termed as tension forces. So in your college and all, your professor will say that when we cut a material, the forces they look somewhat like this, so these are termed as tension forces. At any point at the elastic ring or wire, the forces will be like this towards each other. Okay, so these are nothing but tension forces. So again, let me rub this out. So again, here in this pole, I can see the tension forces. So in this pole again, it is stretched from the point B to the point C. So the forces will look like what? The forces will look like this way. There will be one force coming like this, and both the forces will be equal. Both the forces will be equal. They're trying to join the wire, they're trying not to break the wire. Okay, but when we draw this free body diagram, what happens is, in free body diagram, we need not draw this part, ground part, and we need not draw this particular pole part. We just have to show the forces. Okay, we just need to show the forces. So in FDBF, free body diagram, I'm writing over here free body diagram. So in free body diagram, you just show the forces. You just show the forces. Okay. Always the tensile forces will be like this. You see, you show the forces. So here it is 15 degrees, 15 degrees, and here it is 60 degree, and this is my F. Then here it is 40, sorry, 40 kilonewton. 15 degree at 25 kilonewton. Here they are telling me determine the force F in cable if the resultant of three concurrent forces acting at B is vertical. So it is very simple. I need to resolve all the forces. This was 60 and this was 45. I need to resolve the forces, and I have to do summation f of x is equal to 0. If the resultant is vertical, your summation of f of x will be equal to 0. Let me write it over here. Summation of f of x will be equal to 0 because the resultant is vertical. First, let me resolve the forces. When I resolve the forces, one force will go like this, another force will go like this. Okay. So it is 60 plus, actually it is not 60 plus 15. This complete part is 60. If you see carefully, it will be 60 in the books. Okay. So this part is nothing but 60. So it becomes f cos of 60. This becomes f sine of 60. So resolve the forces over here. See, here the angle is 45. This is 45. So this line is parallel. So it also becomes 45. So it will be 40 cos of 45. This part will be 40 sine of 45. Here it will be 25 cos of 15 and 25 sine of 15. It is so simple. Now you do only summation of f of x. When we do summation of f of x, what we will get is, see, 25, sorry, I'm supposed to write over here, 25 cos of 15 minus 40 cos of 45 plus f cos of 60 is equal to 0. So your f becomes 8.27 kilonewton. Okay. Now they are asking resultant. So my resultant will be what? My resultant will be summation of all the vertical forces. So summation of all the vertical forces is 25 sine of 15 in negative direction minus of 8.27 sine of 60 minus 40 sine of 45, which is equal to minus 41.92 kilonewton. So it can be written as 41.92 kilonewton in downward direction. So this is the another problem which can be asked for 4 to 5 marks in University of Mumbai as well as in other universities too. Okay, you just remember about the tension forces. So if anything is tied like this from this point to another point, then in this we will be having a tension force. In examination, they did need not give this arrow. If their arrow is not mentioned, you have to assume that the arrow will be like this. So you just cut this part, you cut this part, and you just draw this thing as the free body diagram. Okay, and you remove all other thing. Only forces should be there in the free body diagram.